Okay, what we're going to do in this video is have a quick intro to the process of solving linear inequalities in one variable. And what we're looking for is numbers on a number line that make this inequality true. And the numbers that make it true will usually be a ray from one point on the number line, like this one maybe this is the number 5, and all the numbers to the right make it true, for example. Before we solve this one in particular, let's make some observations about what happens if you have two numbers that are equal, like 7 equals 7. If you multiply both sides of that equation by 2, you still have a true statement. If you divide both sides by -2, you still have a true statement. That's called the multiplication and division property for equality. But if I take an inequality that's true, like 8 is less than 10, and by the way, this inequality symbol, the arrow points to the smaller number or opens to the larger number. That's how to think of it. If you multiply both sides by 2, you still have a true statement. In other words, the order of the numbers remains the same. 16 is still less than 20. If you divide both sides by 4, for example, 4 on the left, 5 on the right, you still have a true statement. But what happens if you multiply both sides by a negative number? Let's multiply both sides by -2 and see what happens. I get a -16 over here and a -20 over here. And if you think about the number line, -20 is to the left. Here's 0. Here's -20. Here's -16. But over here, 16 is less than 20. So when you multiply by a negative number, the order of the new numbers reverses direction. And that's what's different between solving a linear equation and a linear inequality. If you divide both sides by a negative number or multiply both sides by a negative number, the arrow has to change direction, or we say the order of the numbers is now the opposite of what it used to be. Continuing with this example, if I divide both sides by -4, -16 divided by -4 would be 4. -20 divided by -4 would be 5, and this arrow has gone from greater than to less than. If you divide and multiply both sides of a linear inequality, or any inequality, by a negative number, that arrow has to reverse direction. And this applies even if you have greater than or less than or equal to symbols. That arrow still is affected by multiplying by a positive or negative number. Other than that, you can still move terms around like you do when you solve a linear equation. If this was an equal sign, and you're trying to solve for the one number that makes this true, you might do something like this. You might add 9 to both sides, or think of transposing the -9 from the right side of the equal sign to the left side by transposing it and changing its sign. We're just adding 9 to both sides, so this would be a 24 equals negative 3x. And now if we divide both sides by negative 3, we get x equals negative 8. Okay. Well, we follow a similar pattern over here. We can still add 9 to both sides and get 24 is greater than negative 3x. Divide both sides by negative 3. This will be an x. This will be a negative 8. Since I divided by a negative number, this order changes direction. Now if you want to, you can rewrite it with x on the left side, but the x will still, or the arrow will still open to the x. So x is greater than negative 8 is what makes this true. And if you had to draw a graph on the number line of the numbers that make that true, you'd go like this. Here's negative 8, and we want all numbers on the number line that are greater than negative 8. So we put an open circle here to say the negative 8 is not included. There's your solution set. Pick any number to the right of negative 8, even a 0, and you've got a true statement. If this was or equal to here, the graph, this would be a solid circle, indicating negative 8 is included. And that is where the left side is equal to the right side. X has a value of negative 8. Because we get negative 9, negative 3 times negative 8 is positive 24. Negative 9 plus 24 is 15. That's when the left side equals the right side. Okay, let's try one more of these. Let's try this number 8 here. And we'll go to the second board. Edit, copy, board 2. We want to find out all the numbers on the number line that make this a true statement. We want to isolate that x. So just like if this was an equal sign, we get the terms without x on one side and the terms with x, the constant terms on the other side. So subtract 10. Divide by a positive 5 means that order remains the same. X is less than negative 6. If you're asked to graph the solution set, you'd go something like this, and I'll use a different color. There's the numbers that are less than negative 6 on the number line, and those are the numbers that make this a true statement. Okay, let's see if there's one more here. Let's try this one where we have two terms that contain the letter x. Edit, copy, go to board 3. Let's get the terms that contain the letter x on the same side of the inequality symbol. So let's transpose the minus 4x to the right side by adding 4x to both sides. We get negative 36 is greater than negative 8x plus 4x is negative 4x. Then we divide both sides by negative 4. There's the division. But we remember we divided by a negative number, so this arrow changes direction. So 9 is less than x, or x is greater than 9. You can write it that way. I like to write it finally with the variable on the left side, and that makes it a little easier to figure out how to draw the solution set. Okay, and again, in all of these, if there was an or equal to symbol underneath here, you would just carry that along, and when you graph the solution set, this is a closed circle. Okay. Now some textbooks do it this way. They put the number like 5 here. Let's say that x is greater than 5. They'll use an open parentheses for, instead of a circle, we'll use a left parentheses. And if it's x is greater than or equal to 5, they use a bracket symbol. So you have to determine what's expected from your textbook. There you go. Hope that helped, and I'm going to send some problems for you to try in addition to the ones that you posted in this PDF file. Okay, so I'm going to end the video and send it along.